Hi, everybody. I wanted to take a second to present our transfer of energy in an ecosystem part 2 slideshow. So the first thing we're going to talk about is food chains. So this is a learning target where we create and interpret a diagram of a food chain and a food web. So to the right, we have 3 examples of a food chain. The first one has 3 organisms in it. The second one has 4. And the third one has 5. So the first thing I want you to notice is that the arrows are pointing in a specific direction. This is showing you the direction of the energy flow. So if we look at this first one, the energy is originating from corn. The corn is eaten by the rat, and the rat is eaten by the owl. The energy in the corn is passed on to the rat, so the arrow is pointing towards the rat. This is showing you the direction of the energy flow. When the rat obtains that energy and is eaten by the owl obtains the energy from the rat. So the rat is passing that energy on to the owl, and we see that arrow pointing to the right again to show that energy transfer. The same is true for these lower 2 food chains as well. We have different organisms, of course, but we still see the transfer of the energy and the arrows pointing in the correct direction. So here we have carrots that contain energy. The energy from the carrots are passed on to the rabbit when the rabbit consumes the carrots. The energy from the rabbit is passed on to the fox when the fox consumes the rabbit. And then the energy in the fox is passed on to the lion when the lion consumes the fox. Okay, so again, we're just looking at the direction of the arrows, and that will demonstrate the direction of the energy flow in that particular food chain. That's just one possible pathway of energy transfer in an ecosystem. So generally in an ecosystem, we see a lot of different organisms, and typically organisms don't only have one food that they eat. They have several. So this food web, our next learning target, create and interpret a diagram of a food chain and food web. This is an example of a food web, and it's a bit more realistic to what actually occurs in an ecosystem. And that's because, as I said before, typically organisms eat more than one thing. Okay, so if we were to take a look at, for example, a frog, the 2 energy sources that this frog is using, actually, excuse me, 3, is the dragonfly, the butterfly, and the grasshopper. We know that because all 3 of these arrows are pointing to the frog. That tells us that the frog is obtaining energy from those 3 organisms. Okay, so if we look, we start with these berries. The berries are our producer, and they are eaten by primary consumers. So we have a green fly, a butterfly, a grasshopper, and a titmouse. Okay, all 4 of those organisms are consuming berries and obtaining energy from those berries, which is why we see the direction of the arrows pointing towards that other organism. After this butterfly is consuming berries, it's passing its energy on to the frog because the frog eats the butterfly. This green fly passes its energy on to the ladybird, which eats the green fly. The ladybird passes its energy on to the dragonfly. The dragonfly passes its energy on to the frog. The frog passes its energy to the snake. The snake passes its energy to the buzzard. Okay, so this would be our apex predator up here. This is an example of an apex predator. This is an example of an apex predator because there's nothing that's consuming these. They are at the top of the food chain or the food web. Now, if we were to take a look at trophic levels, this just separates the different organisms based on what they consume. Okay, so the first level in a trophic pyramid like this is going to be your producers. Okay, these are plants, algae, things like that. The second is the primary consumer. These only consume the producers. They don't consume any other primary consumers or anything like that. The third is our tertiary consumers, and they would consume both primary producers and primary consumers. And then we have our further trophic levels. We can call them tertiary if it's after secondary. Tertiary is our, tertiary means third. Quaternary would be a 4th one. We can also just call it apex. Apex consumers are the top of the food chain. And then finally, the way that this all returns is through decomposers. They break down living matter and return it to its chemical components. And then those chemical components, like things on the periodic table, can be used by the producers to then generate new energy. So this is something we call the law of 10%, and there's two learning targets here, the flow of energy in an ecosystem. We're going to explain that, and then explain why energy is lost at each trophic level. So first of all, this J is our unit, and it stands for joules, but there are other units of energy as well. So we might see kilocalories. That's what we actually see on our food packaging. It just says calories. They've shortened it, but they're actually kilocalories if you were to get real scientific about it. So only 10% of energy passes from one trophic level to the next, which means that if we start with 10,000 joules of our primary producer, when that's eaten by our primary consumer, only 1,000 joules are obtained by that primary consumer. So we can figure that math out by moving our decimal place one position to the left. That gives us 10%. You could also take this number and multiply it by 0.1, and that would give us still the same answer. That would be giving us 10%. So our primary producers, if this were to start with 10,000 joules, can pass on 1,000 joules to our primary consumer, and then pass on another 10%, which would be 100 joules to our secondary consumer, and then once more, 10 joules to our tertiary consumer. Each of these are 10% of the previous trophic level. The rest of that 90% is being lost through digestive or metabolic processes or through heat. Okay, so it's returned back to the ecosystem. One thing to remember is energy cannot be created or destroyed, but it can change forms. So typically with a primary producer, they're taking energy from the sun and they're using that light energy to produce glucose. And glucose is a chemical energy, and that's like sugar. That's in our foods. And then that chemical energy can be used to produce kinetic energy, which would be energy of movement. That completes our slideshow presentation. There are lots of links in here. So if you're still not sure about the law of 10%, please click on that link. Here's a video about trophic levels. If you have any further questions, please reach out and let me know. I can always Google Meet with you, or we can talk via email. I hope you're all well. I miss school and I miss you guys, and have a great day.